In this video, we'll solve problems where we'll be dealing with equations involving dot products. Here's the first one. Find mod of x vector if for a unit vector a vector, x vector minus a vector dot x vector plus a vector equals to 12. So what we need to do is, we need to find the mod of x vector, the magnitude of x vector. We're given that a vector is a unit vector and we're given that this dot product is equal to 12. Now pause the video, try this on your own. Okay, so let's start with what we know. We know that the dot product is 12, so let's actually find it. If we distribute, we'll get x vector dot x vector plus x vector dot a vector minus a vector dot x vector minus a vector dot a vector. That's the left hand side, right hand side is 12. So can we simplify this? We have x vector dot a vector minus a vector dot x vector. So dot product can switch around, these two cancel out. We have x vector dot x vector minus a vector dot a vector. Now we are taking dot with itself. So this becomes mod of x vector square times cos of 0, that's 1. Same thing here, mod of a vector square times cos of 0, that's 1. But we also know that a vector is a unit vector, so mod of a is 1, so we can just write 1 here. So this becomes mod of x square equals to 12 plus 1, that's 13. We can take the square root. This is exactly what we need. We need mod of x, that's equal to square root of 13. So this is how we can solve equations involving dot products. Let's try one more. A vector equals to 2i cap plus 2j cap plus 3k cap. B vector equals to minus I cap plus 2j cap plus k cap. And C vector equals to 3i cap plus j cap. And what we know is A vector plus lambda B vector is perpendicular to C vector. We need to find the value of lambda. Now pause the video, give this a try. Okay, so it's not directly saying that we'll need dot product here, but look at this word perpendicular. If two vectors are perpendicular, this means that the angle between them is 90. This means that their dot product has to be 0. So this is where we can use the dot product. If these two are perpendicular, we can say that a vector plus lambda b vector dot c vector, that's 0. And now we have the equation. We can use these values of a vector, b vector and c vector to find the value of lambda. Let's do that. So a vector is 2i cap plus 2j cap plus 3k cap plus lambda. B vector is minus I cap plus 2j cap plus k cap. All of this dot C vector, that's 3i cap plus j cap, that's equal to 0. Okay, let's simplify what's inside the bracket first. We have 2 minus lambda I cap plus 2 lambda j cap plus 3 plus lambda k cap. So that's a plus lambda b dot C vector, that's equal to 0. Now when we take dot, we'll have to only look at the components. I dot I is 1, everything else is 0. So we'll only look at I dot I, that's 2 minus lambda times 3. That's 3 times 2 minus lambda. Similarly for j, we have 2 plus 2 lambda times 1. So that's 1 times 2 plus 2 lambda. And for k, we have 3 plus lambda times nothing. This is 0 k cap. So this becomes 0. So all of this is equal to this, and that equals to 0. So now we have a linear equation in lambda. Let's simplify. 3 times 2 is 6, plus 2 is 8. So that's 8 minus 3 lambda plus 2 lambda. This becomes minus lambda. So we have 8 minus lambda equals to 0, which means lambda is equal to 8. So in this problem, we introduced an equation involving dot products. We leveraged the fact that these two vectors are perpendicular. And then once we have the equation, we can simplify. We can take the dot product and find the value of lambda. Let's try one more problem. The scalar product, scalar also means dot. So the dot product of the vector I cap plus j cap plus k cap with a unit vector along the sum of these two vectors is equal to 1. So we need to find the dot product of this vector with a unit vector along the sum of the vectors this and this. So there's stuff that needs to be done. What do we need? We need to find the value of lambda. This is where lambda is. Now pause the video, try this on your own. Okay, let's do this step by step. Let's first find the sum. The sum of these two vectors is going to be 2 plus lambda I cap plus 4 plus 2, that's 6 j cap, minus 5 plus 3, that's minus 2 k cap. So that's the sum. Now we need to find a unit vector along this. How do we do that? Well, we first take the magnitude. We take the magnitude of this. That's going to be square root of 2 plus lambda square plus 6 square plus minus 2 square. Let's leave it as is for now. Now the third step is to find the unit vector. And how do we do that? We take this vector and we divide it with its magnitude. So that's going to be 2 plus lambda I cap plus 6j cap minus 2k cap divided by square root of all of this. So divided by the magnitude. Now this is the unit vector that we need to take the dot product with. Let's read the question again. The scalar product of this vector with a unit vector along the sum of this and this is equal to 1. So now we have the unit vector, we can take the dot product. Taking the dot product will give us the value equal to 1. So let's do that. Let's take the dot product. And how do we do it? Again, let's look at the components. 1 times 2 plus lambda divided by all of this plus 1 times 6 divided by all of this plus 1 times minus 2 divided by all of this. So that's going to be 2 plus lambda plus 6 minus 2 divided by all of this, if we take this as the LCM. So basically we are multiplying 2 plus lambda with 1, 6 with 1 and minus 2 with 1. So this is the dot product. That's equal to 1. Now we have an equation in lambda. We're done with all the vector stuff. Now we need to solve for lambda. So how do we do it? Now let's simplify. Let's first look at the denominator. We have 2 plus lambda square plus 36 plus 4, that's 40. And what's the numerator? We have 2 plus 6 minus 2, that's 6, and then lambda. So let's find lambda. We have lambda plus 6 in the numerator, and we have 2 plus lambda square plus 40 in the denominator, square root of this. So we take this to the other side, and then we square both the sides. What we get is lambda plus 6 square equals to this denominator, 2 plus lambda square plus 40. Now we can expand. We have lambda square plus 36 plus 12 lambda. That's equal to 4 plus lambda square plus 4 lambda, a plus b whole square on both sides, plus 40. And interestingly, lambda square gets cancelled out. So we don't have to worry about this being a quadratic. So lambda square cancels out. What we have is 12 lambda and 4 lambda. So that's 8 lambda. And here we have 40 plus 4, 44 minus 36, that's equal to 8. So 8 lambda is 8, which means lambda is equal to 1.